Hello friends, my name is Tinkercad and we have talking about the temperature based fan controller project which is in digital electronics, and we have used this Arduino breadboard, small breadboard, Arduino and a fan controller with DC motor which is used like a temperature and a temperature sensor with temperature sense, and then fan will be run. In these projects, we have four main components used, like first Arduino Uno, which is microcontroller, runs logics and fan speed. Third, second temperature sensor, which is converted digital temperature to analog temperature, which is specially used for digital conversion to analog conversion. Third, DC fan. In the when temperature sense temperature, then the DC fan runs based on a temperature, which is our project. Third, prototyping tool like a breadboard, jump wires easily connected in circuit. In these projects, we have hardware components so, and software components too, combined component. First, Arduino IDE, which is a software, use the C++ code run in hardware. Second, Tinkercad code editor, and third, Arduino library. Three components are main used in our project. Fourth step is a circuit design in a Tinkercad. First of all, we have temperature sensor connection. Temperature sensor is here, and then this is a temperature sensor output, input, and analog pin. Analog pin is a connect A0 wire with a temperature sensor. This A0 is a sorry, this nine place pin is connected to this digital diode like AND or, and this mixture is a AND or gates, logic gates. Fan control. Fan control is a DC motor which is connected in a temperature sensor because of when temperature senses temperature, and based on the temperature we have used digital motor and run digital motor. Power and ground. Power and ground. This battery 9-volt battery will connect all breadboard power and ground. And testing wiring. All have circuit connected with a different wires. Above we have talked about the software components. We have also do the coding in a software components like Arduino IDE and a Tinkercad code. In the const pin, first of all we have const pin, constant integer fan pin, equal line. Above slide we have shown nine numbers pin are connected in a temperature sensor, and a temperature pin is connected with I0 pin is connected in temperature sensor too. Void setup and a void loop is a basic function in a C++ floating code. Pin mode, fan pin output means fan pin pin mode is connected in fan pin, and then we have output. Basically, this is output is a take in a temperature sensor. Void loop. Void loop means this is an infinite loop. This is infinite loop function. Actually, this is a function. This integer reading num का एक integer लिया, analog read in temperature pin. मतलब ये टेम्परेचर पिन में एनालॉग रीड करेगा तो वो डिजिटल टू एनालॉग कन्वर्जन करेगा। फिर फ्लोट और दिस फॉर्मूला से हमने इस फॉर्मूला से हमने टेम्परेचर को सेल्सियस में कन्वर्ट किया है। if else use, this loop is also if else use because of the different temperature have different fan speed, because like temperature 25 से कम है मतलब फैन ऑफ है, मतलब 25 से या थोड़ा 30 से कम है 25 के बीच में, तो फैन स्पीड मीडियम होगी, और 35 से भी कम से 35 और 30 के बीच में है तो फैन स्पीड थोड़ी हाई रहेगी, बिकॉज ऑफ टेम्परेचर हाई सो फैन स्पीड इज हाई।
Hello, I am Sawan Patel and I will show you the logic of code, temperature sensing and fan speed control. First is a read analog input. As per you can say the per above slide in function read analog input that store A0 pin. Next is convert to temperature. Here is the formula of temperature that convert. So formula is sensor value into 5 divided by 1024 into 100. Next is a use in control logic. What is a using control logic? Temperature data guides fan speed adjustment in real time. What is the use of pulse width modulation (PWM) control? Adjust for fan speed control. How to adjust it? Temperature mapping. Map temperature ranges to pulse width modulation value from 0 to 192 for speed as per you can see in above slide. The next is the conditional statements. If else statement here we can use on temperature. Now we can see the Tinkercad simulation and testing. So if temperature is below 25, then our RPM is zero. It's between 25 to 30. Then our RPM is 8,000 something. Then its temperature is 30 to 35 between. Then our RPM is 16,000 and above 35 to 120 degrees Celsius. The temperature, the RPM remains same, 16,000 something. As you can see, this is a DC motor our Arduino RD battery real world application and enhancement. First is code customization. In the code customization, modify temperature ranges for different climates. Second is a sensor calibration. Improve accuracy thought calibration against reference thermometers. Next is a display integration. Add LCD or OLED display for visualization temperature and fan speed in real time. Function expansion. Incorporate other sensors like humidity or light for a smarter control. Project challenges and solution. First, sensor accuracy. Uh, for now, second is fan control. Choosing a proper transistor ensure stable speed for modulation, so can our fan can stimulate and control it. Next is a power supply, and the last one is a debugging. Careful testing of firing and code eliminates error quickly, so we can carefully put the conclusion and feature work. So now we can say project summary. Fan controller simplifies cooling by automating speed based on the temperature, as you can see in video. Future enhancement, add wireless control and IoT information of things, integration for remote management, open source project code for now lots of open source like Tinkercad, Beats, etc. Learning encouragement, encourage experimentation and deeper understanding for the system. Thank you.